Hello, ladies and gentlemen. So today we're going to be talking about graphing exponential functions. Okay, so exponential functions are essentially any that look like this. Okay, a number with an exponent on it. So this you could also be 3 to the x, 5 to the x, negative 10 to the x, any number. Okay, with an exponent of an x. Okay, that's why they're called exponential functions because of the exponent component. Okay, now if it has a negative exponent, so a negative exponent, then it's a reciprocal. Okay, that means it's like a flip. So I'll show that in a second. Okay, so the do now is going to be to complete this table for this equation. So if we plug in a 3, that's 2 cubed, which would be 8, 2 squared, which would be 4, 2 to the 1, which is 2, 2 to the 0, which is 1, and then 2 to the negative 1. That one's special. So 2 to the negative 1 is a reciprocal of 2. So in other words, it's 1 over 2 to the positive 1. Okay, you can just bring this whole thing down to the bottom of a fraction and then change the exponent from a negative to a positive. Okay, and so now this ultimately equals 1/2. All right, so now we can plug and chug these values. So if we plot these points, let's see, at negative 1 we had a half, so we're about right here. At 0 we're at 1. At 1 we're at 2. At 2 we're at 4. And at 3 we're at 8. So as you can see, and I'll graph it in blue, this graph would do something like this. Okay, and then it will go up really quickly. Okay, this is what's called a growth function. Okay, and it's a growth function when this number in here, I'll rewrite the function over here, when y equals, let's say, 2 to the x, when this number right here is greater than or equal to, let's say, 2. Okay, when it's bigger or 2 or bigger, then this is a growth. Actually, honestly, let me rephrase that. It just has to be bigger than 1, but not equal to 1. This is what's called growth. But if the function now is, let's say, less than 1, that inner part, okay, let me do it in a different color. Let's say green. Okay, that part right there. So x is now less than 1, but obviously not smaller than 0. So that's actually important. So like that. Then it's a decay. Okay, and decay graphs look like this. They start above and then go down. So now let me, excuse me, let me talk some about the growth function, okay? So this one specifically. These are all questions about growth. Is there ever any value of x that will make it y equals 0? No. There's nothing you can plug in to get 0. Is there ever any value of x that will make negative y values? No. Okay. So notice as x goes to negative infinity, which means you go infinitely to the left, this is going to go to 0. And then if you go infinitely to the right, then this goes to positive infinity. Okay. For decay, it's kind of like the opposite. When you go left, you go up to infinity, and then when you go right, you go down to 0, as you can see right here. All right, so what effect does adding or subtracting a value at the end have on the graph of an exponential function? So if you add 2 to the bottom, or if you add 2, sorry, to the end of it, then you just go up 2 units. So the graph would look like this. Instead of like that, we would shift it 2 units, and so now it would look like that, the blue one. All right, and then the other one is the same thing, but now it's down 2 units. So instead of, instead of like that, I'll do this one in red. It went down 2 units. So sure, it has some negative value. That's only because you shifted it. All right. And so now for the first one, it would go the new limit as it goes to the left, it would be 2. And then the red limit, the one where it's shifted down 2 units, it would be -2. So here's the big hint. This right here tells you that end behavior as it goes to infinity. To infinity. Whatever that is, to infinity. That's where it goes. And now this one's, it's positive infinity for both of them, because notice how they both still go up forever. That's going to come in handy on the next page as you start figuring out that, whether the end behavior, that's the word for it. Now, what happens when you add or subtract values directly to the x? Okay, like right here, right on the x. Well, here it would shift left 2 units. So if my graph is this, well, then it would move. That's a little tough one right there. It would look like that. All I did was I shifted it left 2 units. Same thing with the other one. So this would be right 2 units. Remember, it's opposite on this one. So if this is my original, then my new one would probably look like something like that. Okay, again, not looking for perfection. This doesn't change the end behavior. This still goes to the 0 as it goes to the left, and then it goes to positive infinity as it goes to the right. Okay, what happens when you put a negative on the graph? So, for example, a negative on the exponent, instead of the original looking like this, right? Instead of the original looking like this, the new one looks like that. Okay, now it becomes a decay instead of a growth. Okay, and then if we keep on going, now what happens when you put a negative in the front? Well, that's a flip. Not a flip, a flip. Okay, so the original looks like this. Now the flip looks like that. Okay, and then when you put a number in front, that is a stretch or a shrink, depending on whether the value is bigger or smaller than 1. So this one would be, I think it's a shrink, but it just goes up faster if, sorry, hold on. If this is the original, then the new one would look like this. It would go up way faster. Okay, so here is this one growth or decay? Well, this would be a decay. Is this one growth or decay? This one's technically a growth, but flipped. Because the numbers are getting bigger and bigger and bigger. And then this next one, this is still a growth. Okay. Oh yeah, also about the end behavior. Now this one, as you go to the left, this one now goes to positive infinity, and now it drops to 0. This one, as you go to the left, oh, wait, let me change that color. This one, as you go left, you go to 0, but this one now goes to negative infinity as you go to positive infinity on x, because you're going down forever. And then now on the last one, this one goes to 0 as you go left, but as you go to the right, you're still going to positive infinity. Okay, on the next page, you guys are doing this. Okay, I will give you an example of one of these. Okay, but I'm not going to do these. These are the ones I'm going to do in class. Okay, but on a separate sheet of paper, I'm going to give you like a little example. You don't have to write this down if you don't want to, but I highly recommend you do, so you have it tomorrow. So let's say we have a function like this, and I want you to graph it. So y equals -5 times 1/2 x to the -1, sorry, x minus 1, and then -1 after all. So if you have, let's say, a 1/2 to the x, remember this is your decay function. Okay, that's a decay function. But if you have let's say a 2 to the x, this is a growth function. So you have to learn how to work with that. Okay, so now let's see if we can figure this one out. I recommend you always draw the original so you know what you're working with. I know that this has been shifted 1 unit down, so 1 unit down. Talk about what happens. All right, we're also shifted right 1 unit. All right, because this, and then because of this. So that's this one, and that's this one. Thanks to the green one right here that I'm circling, we've been flipped. So let's see, flipped upside down. And then we have a stretch by 3. Sorry, a stretch by 5. Okay? And then we know that this would be a decreasing graph, or a decay, sorry. So I drew that wrong. The original should look something like this. Okay, because it's a decay function thanks to the 1/2 inside of there. So now let's see, we shift it 1 unit down, we flip it, and then it stretches by a factor of 5. So let's see, that would look something like this. And then the asymptote right here, where it kind of patterns out, that's also because of this. That is your end behavior. So as the limit as x goes to right forever, so to infinity of f of x, that would be -1. But then because we shifted 1 unit down, but then as we go to the left forever, so to negative infinity, left, that does go to negative infinity because it does go down forever. Okay, so this is kind of what I want to see on every single question on the next one. Okay, all right, ladies and gentlemen, you have yourselves a wonderful evening. I will talk to you guys tomorrow.